Hi, my name is Zhang. I'm doing a 6-minute report on the Hyperloop. The Hyperloop, I'm going to start off by introducing it and then talk about the test track that SpaceX built for their pod competition. And then I'm going to talk about the LSU's team design for their pod. And then I'm going to wrap it up with conclusion. So, first of all, why Hyperloop? When California first approved their high-speed rail, Elon Musk was like, this is not a good idea, why are we building this? Because we're investing so much money in a new mode of transportation, it should be like actually better than what we already have, such as driving and flying. His argument was that I think the estimated amount was 68 billion or 69 billion for the high-speed rail. That's a lot of money. So he's saying for a new mode of transportation, it should be better in the sense that it should be lower cost, it should be safer, it should be faster, and it should be probably immune to the weather or natural disasters, among some other benefits. So he suggested Hyperloop, what is Hyperloop? To explain it, you can think of like two extremes. So one, if you've ever been to a bank, if you've ever been to, I guess, the drive-thru, there's that tube where you take out a pod, you can put your deposit in and put it back in, and it shoots like very high pressure air and sends it to the teller. Some very big building use that to send around their mails or sort their mail. That's like one extreme, but it doesn't really make sense because for a track, what they're proposing is from San Francisco to LA. That's like 350 miles. It's almost like blowing into an infinite long straw. There's so much loss in that straw that it's impossible to blow air through it. So that's one extreme. The other extreme is somebody suggested building a tube with hard vacuum or near hard vacuum. That's pretty much really hard to accomplish because any small leak or the fact that they're trying to commercialize this, meaning thousands of people will be in and out of it like every day. So it's really hard to maintain that very hard or hard vacuum. So what Hyperloop is, it's like in between those two ideas. It's a tube that's kept at a partial atmosphere, I think a third of atmosphere. That way you're still going to benefit from the less atmosphere because there's less resistance. But a problem with that is that there's actually some atmosphere in there. There's a problem called the contour width limit, which pretty much saying you need to have a minimum of cross-sectional area of the pod. That's the thing you sit in, I guess, that's being transported in the tube, like the cross-sectional area of that versus the cross-sectional area of the tube. Because if it's too close, if the diameter of the pod is too close to the diameter of the tube, when this thing's going fast, it's pretty much going to end up pushing the whole column of air in that tube, which is very inefficient. There's two ways around that. Is you're really going really fast as a transonic speed, or no, a supersonic speed. There's some problem with that. Is like going even with a really wide turn, going at a supersonic speed. There's an insane amount of G-force, and going from subsonic to supersonic. That's a pretty dodgy process right there too. So another thing that overcome it is going really slow, but the point of transporting somebody or having a new mode of transportation is to be faster. Well, for their design, now SpaceX, actually I say this, for SpaceX is actually not making a Hyperloop. They just came up with the idea. Elon Musk is not investing, or at least not building one himself, but their original sketch is to overcome this contour limit is to put a fan in the front. This could benefit in two ways. Again, it'll help push the air around the pod, so pretty much won't have to deal with the whole column of air issue. Another, it'll provide air cushion, like the concept on the air hockey table. It's really low friction, so this thing can travel faster. So there's that problem. So pretty much the benefit, like I was explaining earlier, for a Hyperloop is that it'll be cheaper. He estimated about in a few billions versus in the tens of billions for the high-speed rail. It's also immune to weather because it's inside a tube. It's essentially self-sustainable because this is not to put a solar panel on top of their track, and also it's immune to earthquakes because it's on pylons. The reason why it'll cost less is because because instead of buying up land for the track for a high-speed rail or pretty much a bullet train, is that these pylons, it could go over, so you don't have to buy the land there to build this. So that's the benefit of having Hyperloop, and why it should be the next mode of transportation. Some components I was playing with the pod itself, the tube, the pylons, and the solar panels. So for SpaceX, again, they're not investing, they're not making their own, but they would like to, I guess, encourage people to do this. So they built a they built a test track, and this is the drawing for this track. There's some limits that you have to keep in mind while building a pod for competition. Is that there's a keep out zone, like on top of the tube. There's also a keep out zone for this I-beam that goes in the center. This I-beam is where the pod will center about, and it's used for different things. Some people use it for braking. The LSU team is actually using a motorcycle wheel that is activated by actuator, and it comes in contact with this. And also attached to the pod will be a shaft, and there will be bearing wheels here. So pretty much as the actuator lowers the wheel, they'll clamp down on the track, and that's what they're going to use to reach their speed before they disengage that. And that's where the magnetic drive take over. So again, their suspension is magnetic levitation. They will use the wheel to provide initial, I guess, lift off the ground. Like I said, the wheel will be right here. There will be axle coming in that's attached to the pod itself. And on the axle there will be bearings and an aluminum wheel. Another thing we have to keep in mind when designing this is that the wheel itself, it's made out of aluminum, is less hard than the aluminum track itself. So we don't want to damage the track. Because the track is the most expensive thing of a Hyperloop, is the track itself. So there's that to keep in mind. So we pick an aluminum wheel that's less hard than this. The propulsion system, like I said, is it's going to be on the pod itself. Again, they're using a motorcycle wheel driven by an electric motor. Some other team is using their launcher. It's like a pusher almost that pushes the pod really, really quickly to achieve the speed. Some have a special kind of propulsion that's off the pod itself. That's really up to the team itself on how they will achieve that. Some other things to keep in mind for when designing this, that they require safety factor 2. So for the axle that was going through here, I did some calculation and came up with some numbers and had to pretty much multiply that number by 2 to make sure I choose an axle that's rated for the safety factor. I ended up choosing a stainless steel axle. The ball bearings were stainless steel ball bearings.